So let's start another topic, that is all pair shortest path. So very popular algorithm for this particular problem is Floyd Warshall algo. Floyd Warshall algo. So if you remember our last lecture, single source shortest path, we have seen about De Castro algorithm, and another example we have seen about Bellman-Ford. Both two examples are basically for single source shortest path. Means what? If a source is given to you, let's say vertex 1 is given to you, you want to find out a shortest path to all other vertex from this source, then De Castro algorithm works good. But you know the problem with the De Castro algorithm single source is what? It does not work well with if the negative weights are there. Let's say weight is -2, this is 1, this is 3, this is 4, let's say. Then in that case, De Castro algorithm may or may not give you good results. So we have seen another example that is known as Bellman-Ford. But Bellman-Ford even works good with your negative weights also. So it works well with negative weights also. So these two are the algorithm we have seen, but these two are the example of single source shortest path. So I hope meaning is clear to you. If a source is given to you, single source is given to you, how best shortest path you can choose so that you can reach to all other vertex. Same problem, but these two both approaches are based on approach of greedy method. So one of the programming popular approach of designing any algorithm is based on greedy approach. So both De Castro and Bellman-Ford are based, you can say, based on greedy method. So it may or it works well with this particular thing. But same method you can apply to find out all pairs shortest path. First of all, you try to find out what is the problem with statement of this all pairs shortest path. Means is what? If 1 is my source, then what is the shortest path to reach to 3 and 4? So this is if given a root from 1. Second problem could be that if the source is 2, how to reach to 1, 3 and 4. If the source is through 3, then how to reach to 1, 2 and 4. If the path is through 4, then how to reach is to 1, 2 and 3. Meaning is what? Given any source, how you could reach to a path to all other pairs. Means all pairs shortest path. Means what? This particular method should give us, if I want to reach from 3 to 2, out of n number of path available, 3 to 2, we can go directly. Through 1 also we can go, through 4 also we can go. So there are several paths to 4. Which one is best path? So all pair shortest path meaning is, you will go through intermediate vertex also, all other vertex, and you will try to find out shortest path between this source to this source, either directly or through indirectly through intermediate path. So this is basically a problem. You are trying to find out all pair shortest path. How you can solve this problem using De Castro also? You can solve, because given a single source 1 is given, what is the best path we can get? We will get after applying De Castro algorithm once. Changing the source again, let's say source is 2, again we can find out De Castro algorithm and we can find out the best path available through 3 also, through 4 also. But this algorithm should run at least 4 times. So time complexity of this algorithm will be nothing, it's an order of n, and basic De Castro algorithm time complexity is n square. So it will be approximately order of n cube. So in order to not to run the algorithm multiple times by selecting every time new source, you basically follow a single method that is known as Floyd-Warshall algorithm. So this algorithm you will call once, and strategy of algorithm is such that it will give you a path from any source to any destination, and that path will be least in cost, and it will also support negative weight. The Floyd-Warshall algorithm is an algorithm which supports negative weight, and it gives you a shortest path between any pair of vertices given in a graph, and it is shortest answer. Fine. So that's all about basics of Floyd-Warshall algorithm and all pair shortest path problem. Fine. So I hope things are clear to you, And now I will tell you what about Floyd-Warshall algorithm and how basically this algorithm works on any graph. So that's for introduction to Floyd-Warshall algorithm and all pair shortest path. In the next video, I will tell you one example, and through that example, how basically Floyd-Warshall calculate the shortest path between all pair of vertices, so that answer will always be minimum in cost. Thank you. In the next video, we will see how numerical as well as algorithm for Floyd-Warshall algorithm. Thank you.